Okay, in today's video, we're going to talk about linear systems using elimination. So we're going to use this elimination method. So let's discuss why this method works or what it is before we even get into any examples. So the elimination method works because the addition and the subtraction properties of equality. And that's important to understand why it works. We can use this method because of these two properties and because of the zero product property. The zero product property is something that we already know. It should be a P right there. Essentially what this property is, any value times 0 is 0. So anything times 0 is 0. So 0 times b is 0, 0 times 5 is 0. When you multiply 0, the outcome is 0. We already know that. We're just formally defining it. So consider this equation right here. Negative 3x plus 6y equals 9. And I want you to think back to substitution when we had y equals x plus 3. What we talked about was because the equal sign says that this value right here is the same as this value right here. If we put them on a scale, they would equal each other. We can take a y out and we can put in an x plus 3. So we can take this y out right here and we can put x plus 3 because they're equal. Even though they don't look the same, they are the same. So think about that while I show you why we use these addition and the subtraction properties. So consider this equation. Because of the addition and subtraction properties, we can add whatever we want to both sides as long as we do it equally. So for example, we can add to the left side, we can say, okay, let's add 5 to the left side, just got to make sure we add it to the right side. Or if we wanted to subtract x to the left side, we just got to make sure that we subtract x to the right side, as long as what we're subtracting is equal. So what we're going to do is we're going to take this concept and we're going to use it to solve this system. So here we have two equations. And what we're going to do is we're going to add 3x plus 3y to one side, and because this equals this to the other side, we're going to add 18. So although what we're adding to both sides does not look the same, they are the same because of the equal sign. So we have 3x plus y on the left side. We're going to add 3x plus 3y. And because we're adding this, we've got to make sure we add equally to the other side. And because 18 equals what we added to the left side, we can just add 18 to the right side. So we're adding this to both sides, we're adding that, and we're adding this. And now we can just simplify. So we add up our numbers. X's, our x terms, negative 3 plus 3 is 0, x. And 6 plus a positive 3 is a positive 9, y. And 18, or 9 plus 8, a positive 18 is a positive 27. So you can see when we add these things to both sides, we're able to combine our like terms. So we intentionally did this because now you can see in front of this x we have a 0. So now we can use the zero property, product property, which says 0 times x is 0. So we have 0 plus 9y equals 27. And now we have one equation with one variable that we can solve for. Now we can go ahead and find y. So this is what the elimination method does. It allows us to add equations together or subtract equations together so that we can figure out what one variable is and then find the other variable. So let's go ahead and go over an example that we might see. And the steps are to the right. So as I'm going through this example, make sure you pause and get the steps down. So our first step is to identify the factors of each variable and which ones add up to 0 or subtract to 0, right? So if we look at the factors or the coefficients of x, we've got a negative 9, we've got a positive 9. Some of you already identified them. Negative 10 and a positive 6 for y. And we know that by looking at them that negative 9 and 9 are opposites, and we know that opposites add up to 0, so we need to add. That's important here. So what we're going to do is we're going to add the equations together so that we can eliminate x, because we're trying to create the 0, and 0 times x is going to be 0, so then we're just left with the y. So if I write this out horizontally, I'm adding negative 9 and 9 for our x's. For our y's, we're adding negative 10 plus 6 for our y's. And for our constants on the other side of the equation, we're adding negative 10 plus 6. So this is just, if I wrote it horizontally, sometimes you might see it expressed this way, where they're just adding the coefficients in parentheses for that particular variable. what we're going to write in our first blank is what we get after we add them together. So here we're adding to the right side of the equation a 9x plus 6y, and to the left side we're adding a 6. And we're adding equally to both sides because 9x plus 6y equals 6. So let's go ahead and add our coefficients together. Negative 9 plus 9 equals 0, x. Negative 10 plus 6 equals a negative 4. So we just write minus 4y because we don't want a plus or negative. We don't want a plus negative. And then the constants, negative 10 plus 6, again, equal a negative 4. So we just added together using the addition property of equality. So that's important that we type in addition here. Addition property of equality. Sometimes we'll subtract if we have the same number, but we had opposite numbers. Now that we have 0x, we know that 0 times x is 0, and they've already got the 0 in for us. So we're just typing in now what's left. So 0 minus 4y equals a negative 4. Why is 0x the same thing as 0? Because the 0 product property, which we formally defined earlier. Oh, sorry, 0 product property. And now we know 0 minus 4y. Anything 0 added to anything is whatever you're adding to. 0 does not change the value. So we have negative 4y equals negative 4 because of the additive identity. So some of this is already familiar. Done it multiple times. Now that we've got the variable by itself, y, we can go ahead and finish solving. So we got to get rid of this negative 4. It's being multiplied, so we're going to divide both sides by negative 4. So negative 4y divided by negative 4 and negative 4 divided by negative 4. We just use the division property of equality because we divided both sides. Now it's telling us to simplify. So negative 4 divided by negative 4 is 1. They've already got that in there. Times y is 1y equals, and then on the other side we have negative 4 divided by negative 4, which is also 1. So 1y equals 1. And then our last step, we're rewriting this using the multiplicative identity. So 1 times y is just y equals 1, and multiplicative identity. So our third step here was to solve for the remaining variable, which we did. So let's move on. Now we've solved for what y equals. We can use the fourth step and we can substitute to find the other equation. So you can see that this example is a little bit different. So this is the same exact set of equations, except the first couple steps we're doing a little bit differently. You can see this justification says solve by elimination. So here we're proving that the method works, the elimination method. We're proving why. We're using all these identities and properties. Here, we don't have to prove that anymore because it's assumed. It's like, guys, the elimination method works. We don't have to prove that. So you can see that I've already filled in where we left off. We left off where y equals 1. We added, we simplified, we divided, and we got y equals 1. So our fourth step here is to substitute the value into either equation. They've given us the equation that we're using. Looks like they used the top equation. You can see that right here. So we're taking the value 1 and we're interchanging it with y just like we did in 5.2, substituting, interchanging y with 1. And now we can go ahead and simplify. So negative 9x minus 10 times 1. So negative 10 times 1 is a negative 10. So in this blank right here, we're writing in a negative 10. So we've got negative 9x minus 10 equals negative 10. We're only typing in that part right there. Now we're using some sort of property of equality. So now they're getting rid of the numbers. The number that we're gonna get rid of here, obviously, is the negative 10, the number that's being subtracted. How? We're gonna add. We're gonna add to get rid of it. So we're using the addition property here. So what are we typing in this blank right here? Well, we have negative 9x. We have the minus 10 that we have to type in from above. And then we're adding 10. So we're typing in that on the left side. On the right side, they give us the negative 10, and we're typing in a plus 10. So we're adding that. Now that we simplify, we know that these simplify to 0, and they already simplified that for us. And we know that negative 10 plus 10 also simplifies to 0 on the other side. Then we use the additive identity. We don't need to write the plus 0, so we have just negative 9x equals 0. And now it's time to get rid of the negative 9. So we're going to divide. So negative 9x divided by negative 9 equals 0 divided by negative 9. When we simplify, we get negative 9 divided by negative 9 is 1, and 0 divided by negative 9 is 0. And we can use the multiplicative identity to write it as just x equals 0. And then our solution, again, in coordinate points, we have 0 for x, which comes first, and then for y, we had 1. So this would be our final answer.